Hello everybody and welcome back to Operation Logistics, where we've got an issue with our month tick here. Now, the first thing I want to do is I want to make this a little bit more clear what's happening here. So this is in our month incrementing. So let's go ahead and say while value is less than month.January, and then we'll set our value directly to be month.December. There we go. And then while value here is greater than, not equal to, less than or equal to, oh well there's a big problem. But while this value is greater than month.December, year plus plus value equals set directly to month.January. Okay, that should help, because this was definitely a big issue. So let's go ahead and unplay this, bring our faster speed, for now, back up to 1440. We obviously don't want it to be at that speed forever. That's just a little insane, but that's for testing purposes. And we'll just go ahead and run this at the fastest speed we can. And we'll see if this month tick works a little bit better. Hopefully it does, because it came up with an unknown month in a really wacky year. But in part that was because of that sign issue, and now we know for a fact that it's just toggling between January and December as it increments. So it should work better, but we're about to find out. 31. Whoa now. Whoa, 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 whoa. It skipped from 31 directly to 2. Well, that's not right. So, while value is greater than get days in month, month plus plus, we're just going to say value equals 0 directly. And then here, while value is less than 0, month minus minus, value just equals get days in month. That should fix that issue. And I'm just checking our signs here. That appears to be correct. And let's run this again. And I do eventually want to make sure the year tick is working as well. That's going to require an even faster speed than what we're testing with right now. In fact, I'm going to go ahead and upgrade this right now to 2880. This is way faster than we want the game to be running at later on, but that's fine. Let us test. Zero February. Oh. I know what the problem is. Days are 1 indexed, not 0 indexed. What am I thinking? Also, hang on a moment. I think I just accidentally launched Mod Organizer. Go away, Mod Organizer. There we go. Okay, so let's go ahead and try this again, now that we're no longer 1 indexed. Or rather, we're no longer 0 indexed. We should still be 1 indexed. So let's see. 31, 1 February. Yeah. Okay. So now we need to make sure the year tick is working. And I'm going to go ahead and pause this so we don't lose our current progress. And I'm going to bump this up another 4 times to 11,520 seconds, or minutes per second. There we go. March. April. May, June, July, August, September, October, November, December, here we go. Aw yeah, back to January in 2001. Perfect. Well, I would say our time system is now working. I'm going to bring this back to a faster speed of 20. And the question then is, what do we do next? It's a good question. We could test our leap years, but that should be working just fine. Everything appears to be working in our moment class, so I think we're good to go there. So that should be excellent. And no, I don't want to run a search Visual Studio. Go away. Okay, so the question now is, how do we get started? Because we have everything in place-ish for a lot of our game logic to be starting to be written. We've got our test company name here that we can set. We can set it to be blah. There we go. Our test company name is now blah. That doesn't actually do anything. It's just visual. So let's actually go into our business class here. And I'm going to get rid of that for right now. We might bring that back. But for the moment, this is all we're going to need. And I want to first have a public string business name, and then a public void onChange business name. There we go. This is definitely also going to be needing using UnityEngine.ui because the business class will be responsible for doing a lot of the, like, driving a lot of the UI elements, most likely. This is kind of going to be our, well, this is where our core game logic is going to be, essentially. So onChange business name, we're going to go ahead and have a reference to our business name field. So this is a TextMesh Pro field, tmpro. What do they call their input field? TMP input field. And this is going to be business name field with an L. There we go. And then down here, business name equals business name field dot text. Okay. So now we should be able to set this up as soon as we actually create an instance of the business script. Yes, never assigned to blah blah blah. It will be assigned. Oh, it's not public. That's why it's complaining. There we go. It will be assigned in the inspector. So we'll go ahead and do the business here. Place that right on in there. And then our top bar here, so our company name field goes directly into the business name field. And then the business name will be run off of that. So the company name field also is going to need onValueChanged or onEndEdit. I'm actually not sure which we want. I think onEndEdit is the one we want. So let's go ahead and do that. So company name field, no, not company name field. Hang on, let me undo that. There we go. So onEndEdit, we're going to grab in scripts, business, onChange business name. Okay. So now we're in here. We can see our business is unnamed, and we can run this. And when we do, our business will remain unnamed until we type in a test company name here. Actually, I'm going to go with the good old Green Death Legion. And actually, I'm noticing as we type, WASDA is still a thing. So there's that. But I'm going to go with the Green Death Legion. There we go. And if we go into here, you can see it automatically updated our business name in the script to the Green Death Legion. Excellent. So the next thing that we're going to need is we are going to need some financial information. So let's go ahead and do a header, finances, and this is going to be a public float. We are going to use a floating point number. They have plenty of precision for what we're doing here. We're not going to use a decimal. It's a video game. Doesn't matter. Besides, we're not going beyond 2 decimal places. So public float, and this is going to be current funds. And then I'm just going to set that to 0f. And then the next one that we're going to be doing is our expected expenditure and our expected income. So public float expected expenditure equals 0f. Public float expected income equals 0f. And based on the way that the amount that you get paid is calculated, that number will probably bump up and then just tick down over time, and then keep bumping up and tick down over time. But we'll see. So there's our finances header there. And we're going to need access to this TextMesh Pro text field here. So let's go ahead and get a public tmpro.textmeshpro UGUI. And this is going to be the financial text. Okay. And we are actually going to need a void update, because we're going to need to be updating this pretty frequently, basically every frame. And then we've got all of this here. And this is going to be interesting, trying to keep all that updated. We're going to need a fair number of variables. So above our finances header, I'm going to go ahead and put in a header for balance variables. Now, these variables are going to be used to determine how much these assets up here cost. So, public float plain cost, and this cost will be per day, I think. That's the theory, anyway. Also, I just had a thought. So, for right now, I'm going to say that a plane is going to cost, say, I mean, up here we have it as $250 a day, which is probably fine. But I just had a thought. We're probably going to want to add in the ability to do time ticks in our time manager. So let's go ahead and create a function here. And we will call this public void on minute tick. Not much is going to happen on the minute probably, but public void on hour tick. Public void on day tick. Public void on month tick. And finally, public void on year tick. Now those don't currently do anything. However, when we're in here, actually we can do it in... I suppose we could do it here. I'm just thinking here about how we want to determine these. I mean, realistically, the minute tick is gonna happen multiple times per second, and I think we don't need a minute tick. However, let's just go ahead and do right here, moment old moment equals current time, like that. So now we have a reference to our old moment, and then we have a reference to our new moment here. So if old moment dot hour is not equal to current time dot hour, then we can go ahead and run our on hour tick. And then we'll just go through and check all of these other ones here, hour, day, month, year. So if old moment dot day is not equal to current time dot day, then we will run on day tick. There we go. If old moment dot day, or rather dot month, is not equal to current time dot month, on month tick. If old moment dot year is not equal to current time dot year, then we will do on year tick. Okay. So every time that an hour, a day, a month, or a year ticks over, one of these functions will be called. Now the next thing we probably want to toss in here is I'm thinking we want a superclass here. We definitely want a superclass here. So let's go ahead and hop into our core and create one. So I'm going to create a C# script. There we go. And no, I'm going to delete that. Hang on. I'm going to unplay this. There. Delete new behavior script. Create new C# script. And this is going to be entitled, we'll call this something about a time class. So this is a class that is designed to have the ability to register itself with the time manager, and then the time manager just goes through every time one of those ticks happens and calls the relevant one on that object. So every object can easily know when the time tick happens, essentially. So this is going to be a time-aware object. We'll call it that. Okay, so in the time-aware object, it is going to be a mono behavior, but it's not going to have a start or an update function by default. All it's going to have is a public virtual void on hour tick, public virtual void on day tick, public virtual void on month tick, public virtual void on year tick. There we go. And actually, I need to declare a body. There we go. The other thing that all time-aware objects will have is a reference to the time manager, and that can be private. Private time manager, and then a void start. And I'm going to go ahead and make that a virtual void start, but by default, virtual or abstract members cannot be private. Okay, protected. Maybe a protected void? Yeah, that's fine. So protected virtual void start is then going to be, all it's going to be is grabbing a reference to the time manager. So manager equals game object dot find. Actually, just find object of type. And this is going to be of type time manager. Okay, so it just grabs that at the beginning of the game, and that's it. Find object of type time manager. So every time-aware object will know about the time manager and will automatically register itself here in a moment. So we need to get that set up next. So let's go ahead and save this and open up the time manager again. And we will create a list here. Public list of time-aware object. And we'll just call this TWOs. Twos. I mean, yeah, that's fine. Equals new list of time-aware object. Like so. Okay, and then the object will just add itself to the list. So manager.twos.add this. Okay. So in the business class, this needs to be a time-aware object. So we'll make this be, oh, come on, time-aware object. There we go. So business is now a time-aware object and now just automatically has access to all of the things that the time-aware object does, including these functions. So the next thing we're going to do is in our time manager, in these functions here, we're just going to say for int I equals 0, I is less than, and this is going to be 2's.count, I++, and it's just going to say 2's I dot on hour tick. So it's just going to iterate through the whole list, and every time an hour tick happens, it's going to go ahead and just call that on hour tick. Same thing here, except instead of on hour tick, it's going to be on day tick. And the same thing here, except it will be on month tick. And I think you can see where I'm going with this. In this next one, this will be, get this, on year tick. That was out of left field, I know. But that's just, sometimes I like surprising people. It'll be great. So now our business will be able to implement these functions. Like, for example, say we wanted to know every time a day tick happened. Public override void on day tick. And then all we got to do is say something like debug.log day tick happened. And now if we run this until we have a day tick, we should immediately be informed down here when a day tick happens, which will be a little while. Maybe 20 is a bit slow. Maybe we should have the fastest speed be like an hour per second. Actually, I'm going to go ahead and do that. Let's have the fastest speed be 60, the fast speed be 30, the play speed be 15, and the pause speed be 0. So it continues to double every time, but we just increased the speed pretty substantially across the board. Okay, so we are now proceeding much faster, and we should, as soon as the day tick happens, be receiving a notification that the day tick happened from the business class. Which of course is not where the day tick is. So as soon as we hit 2 January... Why did we not get day tick happened? We register with it. Is the registry not working? We'll find out. Let's see. That should have worked. Okay, yep, business is definitely here. So that means that the day tick isn't properly being called. So if that's the case, then let's go ahead and check in the time manager here. If oldMoment.day is not equal to currentTime.day. We change it here. I kind of want to check debug.log oldMoment.toString, and then on a different line, debug.log currentTime.toString, but we'll do that after our ticks here. And then I'm not going to maximize on play this time because I want to be able to see our console. And let's just see what's going on here. I mean, obviously it's all returning the same right now. Okay, let's pause this. So, 304, 305. And I'm just going to say something like this. Old plus that, and then new plus that. Also, if current speed equals pause speed, we can return instead of breaking. if we're paused, there's nothing we need to do, right? So it's fine. No need to do all of this stuff. So now it shouldn't output anything if we're paused. And it should only output when we're playing. Let's go ahead and play. Okay, pause this, and old is... Yeah, these are definitely different. Let's just keep checking, and we'll check right at the day tick. We're about halfway there. Okay, let's see. So here's our day tick right here. So old is 1 January, new is 2 January. If old moment.hour is not equal to current time.hour, old moment.day is not equal to current time.day. Okay, let's check our moment here. Where is our moment script? Here's our moment script. Day returns backing day. And then sets backing day. So that should be completely irrelevant. We override the on day tick. We know it's registered. So because it's registered, that means that the time manager is not calling on day tick here. Old moment.day not equal to current time.day. So old here is 1 January at 23:59. New is at 1 minute 2 January 2000. So old and new days are obviously not equal. So why did it not call on day tick? I'm not sure. However, it is time to put a cut in here. I'm going to continue puzzling on this one, and next episode, we'll solve that particular issue. See you all then.